Okay, I believe this is day 6. Normally, I don't know with distance learning what day this is for polynomials. But we're going to work on polynomial and rational inequalities. Now, let me start by saying, if you had a tough time in Unit 1 when we were learning about functions, where determining where the graph was, like f of x is greater than 0 or f of x is less than 0, then you're going to have a hard time with this because it's the same thing. We're just doing it in a slightly different way. So let me just go ahead and start the lesson, and I'll explain what I just said again in a little bit. So steps for solving polynomial inequalities. So step 1 is first they give you an equation, they give you, and they ask, where is x squared is less than or equal to 4x plus 12, for example, in this example. So step 1 is to write the inequality so that the polynomial expression is on the left and the zeros on the right, okay? So you just have to be careful about the sign. If you're adding or subtracting, it stays the same. Step 2, then you're going to determine the numbers at which the polynomial expression on the left is equal to 0, okay? So usually that involves factoring, like this problem. Once you have it factored, then you're going to place the numbers from step 2 on the number line, and then select the values between the numbers and determine whether the graph is above the x-axis or below the x-axis. And that's the tricky part. And then we'll go ahead and then you're going to answer the question based on what you have on the number line here. Now, how we've been normally doing this, before I go ahead and start this, is by taking a look at the graph. So let's go ahead and do that. So once I get to step 1, and I see I've got a trinomial here, x squared minus 4x minus 12 is less than or equal to 0. Okay, well, let's just graph, let's just graph the, let's just graph this quickly, this quadratic here. So I know I've got zeros. If I factor this out, I'm going to get x minus 6 and x plus 2. Is that right? Yeah. Okay. So I've got zeros at 6 and negative 2, right? So if I go ahead and just plot this, so here's my negative 2 and here's my 6. Okay, we're just kind of estimating here just to give us an idea of what the graph looks like. Okay, and this is a graph, it's got a leading coefficient that's positive, so it's going to open up. So here's what the graph essentially looks like, right? Now, what we're going to do is we're going to take these values, because these zeros are essentially turning points, okay, because the graph on the left of negative 2 here, if I use my highlighter, you can see the graph. This graph is above the x-axis, right? Right at this point right here, at this negative 2, boom. Shoot, I wanted that to be in this hot pink color. Okay, now we've got the graph below the x-axis. Down here, you see? All the way up to the next point. Okay, and now we've got the graph again above the x-axis. You see? So that's all we're going to be doing on the number line. So here, let's go ahead and put our points where we know we've got a change on the number line. And that's going to be, and you have to make sure you put them in order from least to greatest. So the negative goes first, just like a regular number line. Okay, so you just kind of put them on the number line somewhere as long as the negative 2 is on the left and the 6 is on the right of it. And now what we're going to do is we're just going to pick a number below negative 2, like, I don't know, x equals negative 5. Okay, and we are going to figure out what the sign of the polynomial will be if I plug in negative 5 there. Okay, so usually I do that in the factored expression. So in my head, I'm thinking if I plug in negative 5 here, what negative 5 minus 6 is going to make this factor here a negative value, right? Negative 5 minus 6. It doesn't even matter that it's negative 11. It's just going to be negative, okay? And a negative, and then times, this value is going to be also negative. Negative times a negative is going to make the sign of that entire polynomial there positive together. Negative times a negative is a positive. that's going to be above the graph, which we've confirmed, or above the x-axis, which we've confirmed by looking at the graph. So now, the second part, between -2 and 6, we already know by looking at the graph that it's below the x-axis, so this should end up negative. So let's pick a number, and we want to pick the easiest ones, you know, like x equals 0. All right, so if I plug in 0 into these factors, I get 0 minus 6. I'm going to end up with a negative value, and then a 0 plus 2 is going to end up being positive, right? So a negative times a positive is going to give me a negative value, and that the graph confirms that. Now let's pick a value above 6, like 10. If I were to go ahead and plug in 10 into this equation, I would get a positive value times a positive value, which is going to be a positive. That's going to be above the graph. So now, the question is asking, where is it negative? Where is this graph negative? Well, it's between -2 and 6, okay? And it's asking, where is it negative or equal to 0? Since it's included or equal to 0, we have to also include the points on the x-axis. Now, the next problem is asking, where is it positive? And it's saying greater than 0, not greater than or equal to 0. So we are not going to include these points. So let's quickly, let's factor this. This is going to have to be by grouping, right? So this is, pull out an x squared. So we've got an x plus 5 left. And then minus 4x plus 5. Yep, that works. Okay, so what's going to be x squared minus 4, which is x plus 2, x minus 2, right? And then x plus 5 greater than 0. Okay, so I've got points at plus or minus 2 and -5. Okay, so I have to put those on my number line in order. -5 is the smallest number, and then -2, and then 2. Okay, so if I take a look at what this graph is going to look like, okay, we've got no bounces. They're only crosses at these values. So if I was going to actually just in my head kind of quickly take a look at what this graph is going to look like, it's going to be cross, cross, cross. It's from a previous unit, right? This graph is, this is asking where is it positive? It should be positive between -5 and -2, and then above 2. All right, let's just see if that works. So if I plug in -10, I'm going to get, I'm just going to go ahead and use these factors right here. I mean, you can do x minus 2, x plus 2, x plus 5, but I'm just going to plug in a -10 here and then square it. Anytime you square a negative, it's a negative times a negative, makes it a positive. So that's going to be positive times a negative, which gives me a negative. All right, the next value is, let's say we try x equals -3, okay? I will end up with a positive times a positive, which gives me a positive, and the graph confirms that. And then between, let's do 0. If I plug in 0, I will get a negative and then a positive, which gives me a negative. Okay, so far so good. And then maybe x equals 4. That's going to be positive and positive. That would give me positive. Great. Now, where is the graph? Where is it positive? Where is it above 0? Not above, greater than or equal to. Well, it's between -5 and -2. Soft brackets, because we are not including zeros, in union with 2 to infinity. All right, we're moving on for steps to solving rational inequalities. This is pretty much exactly the same, except for now we are dealing with some asymptotes, where that's another point where the graph changes above the x-axis or the y-axis possibly. So we have to include that as our points on our number line. And that's really the only difference. So you can go ahead and read these on your own later. I'm trying to make sure this video is under 15 minutes. But if we go ahead and start and just look here first, okay? This is what we're looking at here. So if I go ahead and it's asking, where is it positive? Okay, where is this graph positive? If I quickly draw a quick graph, see, all right, what is this graph going to look like? All right, we should know this. So once I have this, the numerator, I've got zeros at -3 and 2, right? I've also got, in my denominator, I've got an x minus 1. the quantity squared, which means that I have a vertical asymptote at 1. And the multiplicity is 2, which means the graph is going to be approaching that asymptote from the same side in both directions. So I'll show you that in just a second. So that's not in our curriculum, but it's so useful for graphing. So we've also got a horizontal asymptote at where? Let's see. The leading coefficient is -1 in the numerator, and in the denominator it's 1. So that's going to be -1. So if I go ahead and just kind of estimate -1, so there are my asymptotes, that means that my graph is going to be looking like this. And I know it's on either, this is correct because I've got a multiplicity of 2 in the denominator. So that means the graph has to be approaching the asymptote from going in the same direction on either side. So now that I kind of have an idea about what the graph looks like, I need to go ahead and put my zeros on there, but I also have to put my asymptote on there because as you'll see in the next problem, it could change above or below the y-axis here. All right, so I've got, if I go ahead and put in -4, for example, we're going to start with -4. -4 plus 3 is going to be a negative. If I put in -4 in the second one, I'll get a positive. If I put in -4 in the denominator, -4 minus 1, and then square it, I get positive. And if I look at these signs, a negative times a positive and then divide by a positive, I'm going to overall get a sign of a negative for that value, which makes sense because over here, if I look at the graph, it's below the x-axis. Okay, so you go ahead and you do that for the rest of the problem. And you have to be careful because you'll see, where is it positive? Well, it's positive in 2 intervals. And we've got an asymptote in the middle there. So I've got to not include the asymptote. So we cannot include that 1 because the function is undefined at x equals 1. So x equals 1 is not even in the domain. So when you go ahead and write it, -3 to 1 in union with 1 to 2. And the second one is a little bit more complicated. Let's go ahead and look at the algebra first, right here. This is asking, where is it positive? Okay, this is, what I just circled there is all algebra 2. You've got to know how to do this before you can do these problems. All right, so if I go ahead, I've got 2 fractions. I've got to make the denominator the same. So I go ahead and do that. Multiply 3 by x plus 2 over x plus 2. And then I distribute the 3 using my algebra skills. And then combine the like terms, I end up with x minus 1 over x plus 2. Okay, so if I quickly sketch that graph, I've got a 0 at 1, and then I've got an asymptote at -2, and I've got a horizontal one at 1. Okay, my graph's going to look like, and I know it's opposing sides because the multiplicity of this denominator, this factor in this denominator is 1. So it's odd. So it's going to be approaching the asymptote. The graph's going to be approaching the asymptote from opposite directions. So if I go ahead and put those numbers on my number line, -2 and 1, -2's got to go on the left, and put my values in, I can see that these values are going to coincide. The graph is it's the same values. Okay. When you write your, when you go ahead and write your answer, where is it positive? It's from -infinity up to and including -2. Sorry, not including -2 because the asymptote is at -2. So we're going to put a soft bracket or a soft parentheses around -2 because you're never going to include an asymptote in union with. Now, 1 to infinity. Where is the graph greater than or equal to 0? Well, it is actually greater than or equal to 0 at 1 because that point is not an asymptote. It's an actual point on your x-axis. And at that point, the graph is equal to 0. So we're going to include the 1. So it goes from 1 to infinity. So I guess in summary, you just have to be careful at the asymptotes. Make sure you don't ever include an asymptote in your answer because you don't have a part of your graph is not there. And you also have to be careful about the signs. What if it's the question sometimes asks if it's greater than 0, it might ask if it's greater than or equal to 0. So I think that's it. Peace out.